this one. I know you know how to do this, but be careful, think about it. What is -5 plus 2, ladies and gentlemen? There you go, way to do it. So we've got x equals -3. I have to have both of these answers to get full credit on these types of problems. All right, square root property. I got it, I'm so good at this. I'm a champion, give me my final exam right now. No idea where I am, what is my name, what am I doing here? Oh, you want another example problem? Is that what you're telling me, Christina? Yeah. Okay, I can do you another one. Let's take a look at one more then. D squared equals -72. I'm glad you asked for one more example problem. I wanted to do one more also, so thanks for joining me. Okay, well, I've already isolated the square term, so I should probably take the square root of both sides at this point, yes? Yes. All right, let's do it. So I've got D equals the square root of -72. Traditionally, am I allowed to take the square root of a negative? Yes or no, ladies and gentlemen? No. No, but in the past couple days, we've learned some techniques for dealing with the square roots of negative. What letter am I going to use to deal with this square root of a negative, ladies and gentlemen? I, yes. And what does I stand for, smart children? The square root of -1. Yeah, you got it. So here's how I'm going to deal with this. I'm going to split it up into the square root of 72 times the square root of -1. Then I'm going to simplify that square root of 72 the way that I always know how. So give me two numbers that multiply to get 72 here, Danny.
8.
Oh my goodness, you are so fast. She knew I was coming to her. And then two numbers that multiply to get 9 here, Gianni.
33.
Yes, sir. And see if you can answer this question. I'm asking it a little bit differently. Give me three numbers, three of the same number that multiply to get 8, Emily.
2 and 2.
Yes, ma'am, you answered that question perfectly the first time. So now I'm looking for pairs of factors. Do you see any pairs of factors? Say yes.
Yes. Yeah.
What is a pair of factors that you see, Nolani? 2. Correct, you have 2 2s. And what's another pair of factors you see, Christina?
3.
Yep, there are 2 3s. Are there any unpaired factors that are going to remain in the radical?
Yes.
Yeah, what's going to stay in that radical? 2. So a 3 comes out, a 2 comes out. What's 2 times 3, ladies and gentlemen?
6.
6. All right, so I've got a 6 outside of the radical, a 2 inside the radical, and you told me that the square root of -1 simplifies to what, smart children? I. And we learned today the square root property says I need to put what in front of this answer? Yep, so there's our final answer. I'm glad we did that extra example. Good thinking, Christina. Yes, ma'am.
So with the so whenever you square root, like for this, why didn't you cross out the square for p? Because for this one.
You're right, I should have. Good eye. I owe you a sticker.
Okay.
Yeah, I know, it's confusing when I make silly mistakes like that. Cool. How do you guys feel about 7.1 now? Now you're like, yeah, I'm champions, right? Yeah? Okay, cool. We're gonna cruise. Oh, sorry, what's up, Nate?
How many lessons are we doing?
3, but the next one's gonna be real quick, and the one after that is also gonna be real quick. Okay? All right, next lesson is your favorite thing in the world, the quadratic formula.
What's that?
Oh, wait.
Darn it. Can I read it?
Yes, but you need to wait. Quadratic formula. And we're going to use the quadratic formula to solve a quadratic when factoring isn't an option. So we're going to be presented with problems that look like this. Ax squared plus bx plus c equals 0. A is always the coefficient of the squared term. A is the coefficient of which term, ladies and gentlemen?
Squared.
Squared term. I want to hear all your lovely voices there. A is always the coefficient of which term, ladies and gentlemen?
Squared.
Yep. B is always the coefficient of the x term. B is always the coefficient of which term, ladies and gentlemen? X. And C is always the constant. C is always what?
Constant.
You got it. And we have to have just these 3 terms set equal to 0 before we can use the quadratic formula. And now we're going to use the quadratic formula. Nolina, would you like to stand as you lead us? Okay, you have to like strut proudly around the room because that's how we do it. If you feel the need to strut proudly while you sing the quadratic formula song, feel welcome to. All right? Nolani, choir champion. Equals -b plus or minus square root of b squared minus 4ac all over 2a. Woo! All right. That was some excellent singing skills. Quick 5 clap round of applause for Nolani. All right, so I got x equals, no, just the quick and the 5. -b plus or minus square root b squared minus 4ac all over 2a. So all you'll have to do is identify these coefficients and substitute them into that formula, and you'll have to simplify this formula. Substitution is the biggest part of it, and then simplifying the formula is just sort of some grit and determination to make sure that we get it correct. Some things to watch out for. Make sure that the negative sign is out front. Make sure that this term is squared. Make sure you have this negative sign here. This plus or minus means that at some point in solving this problem, we're going to have to split it into two separate problems, similar to what we did here. Once we've got everything inside this radical simplified, we're going to have to split it up into how many different problems, ladies and gentlemen? Two. All right, and then we'll have to solve two different problems. So almost always with the quadratic formula, we're going to get two different answers. Just be ready for that. We don't need to do any example problems with that because I know you know how to do it. And last on our review list, so this was 7 point something. 2? Are you sure?
I'm positive.
I believe you. 7.2 sounds great. And then we've got 7.4, skipping 7.3. And this is going to be sketching parabolas. Oh, okay, sure. Using transformations. I know, I'm amazed at how many things you know also, and how quickly you know them. It's quite amazing. Suzette, what are you going to remind me of in a minute? Okay, good, thanks. Just want to make sure you're still here. All right, let's take a look. So when we sketch a parabola, I'm sorry, did you guys have a question? Oh, you sounded like you had a question. You were just singing the quadratic formula again?
Yeah.
I had a kid one year rap the quadratic formula. No, you wanted to?
Yes.
Okay, I'll give you a bonus point if you rap it. Do you want to go in the hallway and practice for a minute?
Yeah, let's go. Just kidding.
Okay, all right. Okay, so when we're sketching parabolas, we have to first look at the parent function. The parent function. And the parent function, f of x equals x squared, has a graph that looks something like this. We've got the vertex here at 0, 0, and we've got the general parabolic shape. And now there's 3 different transformations we can look at to manipulate this parent function. Let's take a look at them individually. Our first transformation is going to shift up and down. Ooh, you guys got quiet. You must be wanting to remember this. So an up and down shift will look something like this. F of x is equal to x squared plus or minus, I can't remember if it's h or k, it doesn't matter, we'll call it h. Remind me to use k on the next one. So if I add a value to this parent function, do you think it's going to shift up or down? What do you think, ladies and gentlemen? Yeah, you're absolutely right. And if I subtract h from this parent function, do you think it's going to shift the function up or down, ladies and gentlemen? Down. You're absolutely right. So these transformations make sense. So if I had f of x equals x squared, let's do an example. F of x is equal to x squared minus 2. How many units is it going to shift the function, and in what direction? So a 2-part answer. How many units in what direction? So how many units is it going to shift it, ladies and gentlemen?
Down.
Down 2. South. Sure, we could use south. So my new vertex would be at -2. Nope, just kidding. 0, -2, and the shape of the parabola is still similar. Cool. The next shift will be